theta can be any other angle, not the cos inverse of 2 by 3. Okay, let me apply the conservation of mechanical energy principle. This is R, so what can be this side? And this will be H1. Let's apply the conservation of mechanical energy. What is the condition? I'm going to project the block from me so that it will not leave the circular path at point. Then I'm asking at what angle it's going to leave the circular path. If it not leaves circular path here, mean what should be the velocity here? Should be less than root gr. There's a condition. So now it's a simple mu square by 2. This should be equal to mg h1 plus m vb square. What is h1? U square equal to 2g h1 vb square. Now what is h1? H1 we can write it as, this will be r this will be r cos phi. This total radius is r, no? So therefore what is h1? R minus r cos phi will become this value. Sorry, this one. This is r cos phi. R minus r cos phi will be this particular h1. Let me substitute that. U square equal to 2g r 1 minus cos phi. Okay, what velocity I should project? It depends upon what angle this one. Now it is going to leave the circular path. It's going to leave the circular path at this particular point. So let me call this is. So what height it will descend? Take this is h2. Then applying conservation of mechanical energy, mvb square by 2 plus mgh2 should be equal to mvc square by 2. Then here normal contact, the weight mg, this is theta. What are the equations? Mg cos theta minus n equal to mv square by r. To leave circular path, hc, what is the condition? N should be less than or equal to 0. Or n must be equal to 0, I'll take it, the condition. Substitute that, so Vc is equal to, I'll write one equation. So Vc equal to gr cos theta. Now let me substitute this in this equation. And what is h2? H2 should be equal to r minus r cos theta. Like that, at what angle it should leave, you can put a condition. Let me substitute all the values. mv square, mvb square by 2, mgr, mvc square, vc square will be vb square 2gr 1 minus cos theta equal to gr cos theta. Vb square should be equal to 3gr cos theta minus 2gr. Already you know, or you could have directly substitute this value of Vb square, substitute in this equation. U square, this should be equal to minus 2gr cos phi plus 3gr cos theta. So this gr will keep as it is. So this will be 3 cos theta minus 2 cos phi. Look at the equation now. It all depends. So I think we can go back to, I think like this cos phi is what? From here you are projecting it. So where as you change this angle, corresponding this also going to change. So with what speed you should project from here means that's given. So where it's going to leave and what angle you are projecting. Okay, like this, I need not to say I can release it from rest here. I can project with a velocity, or I can project it from here also. From here also, what will happen? You can work out here. And now, with what velocity I should project so that it will leave circular path at this point. I think what should be the value of VB? If VB equal to root GR, then you're going to get the value of H1. Then substitute, you'll get the angle, or you'll get the velocity. Just I'm telling that one. It's not that already from here also you can project an object. So that first it will pass through the highest point where the velocity will become less than root gr, then it will slide, then it must leave circular path here. Somewhere in this region it is going to leave circular path. You can project from here also. It's not that here, you can project it from here also. Okay. What is U? The block is 8.A, so that it crosses the highest point B and then slides and then leaves circular path. What should be that velocity? Okay, that's what we have put a condition. Any doubt you clarify? After leaving circular path, anything will happen. It is going to describe a parabolic path. That I think it, and it'll come and strike the ground at certain point. Next condition. If this is the hemisphere, we may have a situation where the hemisphere also in motion.